Welcome, and we are going to explore a property of functions that actually applies to trigonometric functions as well. You may recall that functions have this property of being even or odd, and when we learn about even and odd way back when we first studied polynomial functions, we define even as saying if we look at f of x, right, but instead of f of x, we insert f of minus x, so the opposite of x. If we do that calculation out, so insert minus x, carry it through, we get out the original function, and that's how we would show algebraically that a function is even. And graphically, what we would see is that there would be y-axis symmetry. So we fold along the y-axis and we get this mirror image. On the other hand, if a function is odd, we would say that when we insert f of minus, or if we insert f of, or evaluate f of minus x, that when we carry that through, all the signs change, meaning that we have a negative that we can factor out in front of the entire function. So same thing, just all the signs switched. And graphically, we would see rotational symmetry about the origin. So we take it, fix our graph at the origin, spin it 180 degrees, and we would get the mirror image. And so we're wondering, do these properties apply to the trig functions? So we're going to look at cosine first. It just happens to be easier. So we can try the algebraic approach. So f of minus x, this would equal cosine of minus x. And then we're like, well, what is going on here? We can't go any further algebraically. So that means we have to explore graphically. And so we're going to look at the graph, okay? I just went to decimals. I fixed my window a little bit, so it's a little bit more conducive to us looking at this thing. And so if we graph cosine, okay, we know what cosine looks like. And then I have another function, just y equals cosine of minus x. So watch carefully or you might miss it. Did you see it? Okay, I'll do it again. Boom, boom, boom. They're right on top of one another. So cosine of minus x is the same as cosine of x. And actually, if I just disable the cosine of minus x for a minute, again, that even property says that if we look at folding along the y-axis, it should be symmetric. And so you can see it on my screen here, but if we were to fold along the y-axis here, right, we get mirror images. So if we look at like the distance from here to the y-axis, that would be the same as the distance from the y-axis to the other side, and we get a mirror image. So this means that cosine is an even function. Cosine is even. Okay, so in reality, once we evaluate this, this should just be the same as cosine of x. All right, let's look at sine. So is sine even or odd? Okay, and this one, we can do the same sort of exploration graphically. So graph sine, and there we go. Okay, we could look at symmetry. We'll do that in a minute. I want to look at sine of minus x. Oh, that's interesting. Okay, so again, we're comparing the purple on the screen, so sine of x to sine of minus x. And so if I look at, where the purple function is, so like when sine is 0, the other black function is 0. When sine is pi over 2, we're up at 1, right? And then sine of minus x would be down here at -1, so it's the opposite sign. And we'll look at another point. So when sine is at 3 pi over 2, right, we're at -1. The black function is at +1, again, the opposite, okay? And now, so I'm thinking, okay, this one is going to be odd, because if I look at sine of minus x again, just look very carefully. It's only visible for a split second, but if I look at sine of negative x and then negative sine of x, they are the same thing, okay? So that means that this function, the sine function, is odd. Another thing I could do is look for that symmetry, okay? So what I'm going to do is take a screenshot, and I will do this in real time. So we're going to do a screenshot. Let's do that. We're going to copy it, and then I'm going to make 2 copies of this. Boom and boom. Okay, I'm going to move. Oops. I'm going to move them. Okay, so here are my 2 copies. Okay, so this is the original on the left, and then for the oddness, I should be able to take my function and rotate it 180 degrees. So it will rotate around the origin with this. So I just take it, rotate it, like so, and I get the same thing. Okay, so this is showing that property of being an odd function. We can take it, spin it around the origin, and we get the same image. Okay, so sine is odd. Okay, and so if we were to evaluate, say, sine of negative x, again, that negative just comes out in front of the whole thing, and I evaluate sine of x after that. Okay, so conclusions. Cosine is even. Sine is odd. Okay, and actually there's a property that says the reciprocal functions have the same parity. Okay, and when we talk about parity, that just is a word that encompasses even and oddness. So meaning that secant, which is the reciprocal of cosine, this would be even, and cosecant, which is the reciprocal of sine, is odd. Okay, so we'll talk a little bit more about those coming up, but you can use that fact going forward. Okay, now, okay, great, even and odd, fun. Why do we care? For problems like this. Okay, so I'm supposing that sine of A is equal to 0.47. Okay, fine. Evaluate sine of negative A plus 2 pi. Okay, so sine of negative A plus 2 pi. Okay, few mistakes that are common for students to do. Okay, don't do this. I'm going to do it, don't do this. Okay, they say, oh, well, 0.47 is sine of A, so this is just sine of, oh, and I see A is, 0.47, so I'm going to put that 0.47 plus 2 pi in there. No, 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 no. This is saying this whole chunk is the same as 0.47. We do not have that chunk appearing in this expression alone, right? We have a negative going on, we have a 2 pi going on. We cannot arbitrarily put that in, okay? And other students just say that this is, well, variation on a theme here. They forget about the 2 pi and they just say, oh, this is 0.47, okay? Because it must be the same. Or they do something weird. Let's do some thinking instead, okay? Here's the thinking that we want to do. All right, so sine. There's a negative being multiplied by a. Okay, I know that sine is odd, so I know that I can use so if I have sine of minus x, I can say that that's the same as negative sine of x, right? I know I can use that, so I think the negative can come up front. The only problem is this 2 pi is lingering, okay? But what is the 2 pi saying? 2 pi is saying, so again, this is your angle on the unit circle, or your arc length, right? 2 pi is just adding another rotation. Does that actually do anything to the value of the trig function? So we can omit it, okay? If you're just going around the unit circle and stopping at a point, and then you go, or if you go around the unit circle, stop at a point, and then if you go to that same point but with another rotation, doesn't matter to a trig function. So get rid of it, okay? And now we're like, oh, okay, so now I see that negative on the angle or the arc length inside. I'll write arc length there as well. And so that negative can come out front, negative sine of A, and oh, now I see that chunk appearing, right? I have sine of A all alone in there. So then I can say this is just negative 0.47, okay? So making use of that even and odd property can come in algebraically as well as graphically. So be on the lookout for that and be aware of your negative signs.